Hello class, today we're going to cover section 7.6, polynomials and factoring. So, we need to know the basic terminology of polynomials to start with. We need to be able to add and subtract polynomials, multiply two binomials using the FOIL method, find special products of binomials, factor the greatest common factor from a polynomial, as well as factor a trinomial using the FOIL method in reverse, and factor a perfect square trinomial and a difference of squares. So let's start with the basic terminology. A term or monomial is defined to be a number, a variable, or a product of numbers and variables. A polynomial is a term or finite sum or difference of terms with only non-negative integer exponents permitted on the variables. If the terms of a polynomial contain only the variable x, then the polynomial is called a polynomial in x. Examples include 3x to the fifth plus 4x minus 1, or 7, that's also a polynomial, or 8r. So many different examples of what it could be. The greatest exponent in a polynomial in one variable is the degree of the polynomial. A non-zero constant is said to have a degree 0. The polynomial 0 has no degree. A term containing more than one variable has degree equal to the sum of all the exponents appearing on the variables in the term. For example, 4 times x squared times y to the third times z has a degree of 6, because that is the sum of the exponents appearing on all the variables in the term. So in this term here, z actually has a 1 exponent. So you're looking at 2 plus 3 plus 1, which is how we get a degree of 6. A polynomial containing exactly 3 terms is called a trinomial, and one containing exactly 2 terms is called a binomial. All properties of the real numbers hold for polynomials. Like terms are terms that have the exact same variable factors. Polynomials are added by adding coefficients of like terms. Polynomials are subtracted by subtracting coefficients of like terms. Add or subtracted as indicated. So we're going to do an example here. First example A says parentheses 2x to the third plus 3x squared minus 7x plus 1, close parentheses, plus 6x to the third minus x squared plus 2x plus 5, close parentheses. Now, we're adding these two terms here, okay? Because we're adding, there's nothing that can be combined within the parentheses, they can essentially be dropped off for part A, okay? Now, we're going to want to combine like terms. 2x to the third and 6x to the third are like terms. 3x squared and negative x squared are like terms. 7x and 2x are like terms. And I guess we'll do a triangle here. 1 and 5 are like terms. Okay. So what I'm going to do is I'm going to combine 2x to the third with 6x to the third. 2x to the third plus 6x to the third is x to the third. Okay. 3x squared minus x squared, so essentially 3 minus 1 is 2x squared. Negative 7x plus 2x is minus 5x. And 1 plus 5 is 6. I have added as indicated. Okay. Now the next part, part B, parentheses 4m to the fourth minus m squared minus 7m plus 9 minus 3m to the fourth minus m squared plus m minus 3, all in parentheses. Now because this one is subtracted, this subtraction term needs to go to every single term within that parentheses. So basically like the distributive property there. Okay, so what it really is, and I'm going to erase this other work out of the way so that we can start fresh. essentially what we're going to have here, you can rewrite this first part. It all stays the same, and you can drop the parenthesis off a bit. But that negative needs to be applied to all terms of that second parentheses. Okay, so negative 3m to the fourth minus a negative m squared is plus m squared minus m minus a negative 3 is plus 3. Okay, if you didn't catch what I did there, you need to go back and watch. I'm applying this negative to all terms. That negative is going to cancel out the negative there. It's going to add to that m here. And it's going to cancel out that negative on the 3. Now I can combine these like terms. I can combine 4m to the fourth minus 3m to the fourth. That's going to give me an m to the fourth. And then I'm looking here at m squared and m squared. So negative n squared plus positive n squared cancels both of those terms out. And then here you've got this 7m. That's a minus 7m. And then you've got a minus m here. So minus 7m minus m gives you a minus 8m. And then last but not least, you got the 9 here and the 3 here. 9 plus 3 is 12. So you're looking at m to the fourth minus 8m plus 12. Now let's look at the multiplication of polynomials. The associative and distributive properties together with the properties of exponents can also be used to find the product of two polynomials. So let's look at multiplying 3x squared plus x minus 2 times 5x to the third plus x plus 2. Now, let's look at these solutions here. Okay, so with this solution, you can set it up. I'll be honest with you, I don't like how the slide sets it up here. I see what they're doing. I'll walk you through what they're doing. If you like this method, you can like this method. And then I can show you the way I would do it. But what we're doing here is setting it up just like a multiplication. So like if I were to multiply, let's just say, I don't know, let's do 13 times 11. If I was to multiply this, I would do 1 times 3 is 3. 1 times 1 is 1. Drop a 0. 1 times 3 is 3. 1 times 1 is 1. And then I would kind of add them together. So I'd have 3, 4, be 143. Okay, so working kind of the same way. I'm basically taking this negative 2 here to start with, and I'm multiplying it times 2. Negative 2 times 2 is negative 4. And then I'm going to multiply it times x, which is negative 2x, and I'm going to multiply it times 5x to the third, which is negative 10x to the third. Okay, and then after that, I'll change colors on my pen. The next thing I'm going to do is I'm going to multiply by x. Okay, so I'm going to do x times 2, which is 2x. I'm going to do x times x, which is x squared. I'm going to do 5x to the third times x, which is 5x to the fourth. And then I'm going to do 3x squared times all three terms. 3x squared times 2 is 6x squared. 3x squared times x is 3x to the third, and 3x squared times 5x to the third is going to be 15x to the fifth. And then I can just vertically add all these. So I can bring the negative 4 down because it has nothing else to add to. Negative 2x and 2x cancel each other out. Here I've got 6x squared plus x squared, that's 7x squared. Here I've got 3x to the third minus 10x to the third, that's negative 7x to the third. I've got 5x to the fourth, has nothing to combine with, so I bring it on down, and 15x to the fifth has nothing else to combine with, so I bring it on down as well. Okay, that is a way to do it. That is that is the answer. Okay, the way that I was taught to do it, let me clear this real quick. Okay, here's the way that I was taught to do it, and it might be the way you were taught as well. The way that I was taught to do it is the distributive method. So the first thing I'm going to do is distribute negative 2 to 5x to the third. I'm going to get negative 10x to the third, and then I'm going to distribute negative 2 to the x. I'm going to get negative 2x, and then I'm going to distribute the negative 2 to the 2. I'm going to get minus 4. and then I'm going to distribute the x to the 5x to the third. So I'm going to get plus 5x to the fourth. And then I'm going to distribute the x to the x and get x squared, x to the 2, and get 2x. And then I'm going to do the 3x squared to the 5x to the third, and I'm going to get 15x to the fifth. I'm going to do the 3x squared to the x, and I'm going to get plus 3x to the third. And then I'm going to get 3x squared to the 2 here, get plus 6x squared. And then I'm going to have to come through here and combine like terms. I've got 15x to the fifth, has nothing to combine with, neither does 5x to the fourth. So that kind of gets rid of those two terms for me. Okay, then I got to look at the 3's, or the x raised to the third power. I've got a negative 10x to the third power and a 3x to the third power, so that gives me a negative 7x to the third power. That gets rid of those terms. I need to look at the squares here. So I've got x squared and I got 6x squared, so that's going to give me a plus 7x squared. Okay, get rid of those. Negative 2x and 2x cancel each other out. And then I have the negative 4 there. If I did it all correctly, it definitely does. It matches what we've got on the very last step here. So either method just fine, as long as you can get the right answer. All right, let's look at the FOIL method. The FOIL method is a convenient way to find the product of two binomials. So two ones that have two terms each. Okay. The memory aid FOIL, first outside, inside, last, gives the pairs of terms to be multiplied to get the product. All right, so let's try this. Let's try the FOIL method on the binomials here. We've got 3m minus 2 times 5m plus 7. We want to use the FOIL method. First, outside, inside, last. Okay. Now, first, that's the first term is multiplied. 3m times 5m. That's your F. That's your first. Outside would be your two outside terms. 3m and 7. That's your O. Inside would be negative 2 and negative 5. That's your I. And the two last terms would be negative 2 and 7. That's your last. Your FOIL method. Okay. So now we're just looking at 3m times 5m. That's 15m squared. We're looking at 3m times 7. That's 21m. We're looking at negative 2 times 5m, which is negative 10m. And we're looking at negative 2 times 7, which is negative 14. We can combine these two middle terms here. Our 21m minus 10m gives us positive 11m. So our simplification here is 15m squared plus 11m minus 14. And we have FOILed this out and simplified. Now, we do have some special products that we can look at when we do this FOILing. So we can look at the sum and difference of two terms here. If I have a case where I have x plus y times x minus y, it's the special case of the difference of squares. Okay. The reason that is what happens here is if I do first, that's x squared. If I do outside, that is minus xy. If I do inside, that's plus xy. If I do last, that's y squared. As you can tell, minus xy and plus xy cancel out, which leave you with just x squared plus y squared. Okay, sorry. Watch me make an error on film. It happens. It's going a little fast. Y times negative y is negative y squared. Be careful with those negatives. They can sneak up on you even if you think you're doing well. So I get x squared minus y squared. There it is. All right, that's called the difference of two squares. Now, let's multiply this. We have 4p minus 9 times 4p plus 9. And we can always FOIL. We can always first, outside, inside, last and get it. But if we use our special binomial product, because this is a difference of squares, difference of two squares, I should just be able to kind of square the first term and then kind of like subtract it and square the second term. Okay, because it's a special product. So it should be 16p squared and minus 81. okay? If you can't remember that, you can always just FOIL it out. 4p times 4p is 16p squared. 4p times 9, negative 9 times 4p are going to cancel out. Negative 9 and 9 give you 81. So FOILing will always work and always get you out of a jam if you can't remember that property. All right, let's look at the squares of binomials. Okay, so here I have x plus y squared. Essentially, that's just doing x plus y times x plus y. And what happens with that one is you get x squared, that's your first, plus xy, that's your y inside, sorry, first, outside, inside, xy, and then last, y squared. What happens is you have two of those, so you get x squared plus 2xy plus y squared, and that is your special binomial product for a positive binomial squared. Okay, if you look at the negative case here where I have x minus y squared, it's basically the same thing, but the inside winds up negative. Okay, and you can FOIL that out to see that as well if you want to. So if I wanted to, here I could multiply 2x plus 5 squared, and I could memorize this formula if I wanted to and use that special binomial product. It's an addition one, so it's positive on the inside, essentially squaring the first term, multiplying the two terms multiplied times 2, and squaring the last term. To me, I think it's simple enough just to FOIL it, but you could do that as well. Like I said, I could do it probably just as quick here, FOILing it as trying to remember that formula. First is 4x squared, inside is, or outside is 10x, inside is 10x, and last is 25. And then you bring it down to your simplification step, you get 4x plus 20x plus 25. So memorize it, don't memorize it, it's there for you. All right, this one says multiply 2x plus y squared. Like I said, you can use the special formula for that one as well, or you could just FOIL it. It intimidates some people to see the squared on the y sometimes. Don't be intimidated. You're still just doing 2x, it'll wind up being 4x squared. 2x times 2x is 4x squared. Okay, that was your first. If we look at the outside, 2x and y squared be plus 2x y squared. Inside would be 2x y squared. And last, y squared and y squared would be y to the fourth. Then you're just simplifying from there. You're going to get 4x squared plus 4x y squared plus y to the fourth. Okay, easy enough. Now, it gets a little more difficult in the factoring process, but we're going to take it piece by piece, easy problems to harder problems. So the process of finding polynomials whose product equals a given polynomial is called factoring. For example, since 3x plus 9 equals 3 times x plus 3, both 3 and x plus 3 are called factors of the 3x plus 9. 3 times x plus 3 is called the factored form of 3x plus 9. Okay. A polynomial cannot be written as a product of two polynomials with an integer coefficient as a prime polynomial. A polynomial is factored completely when it is written as a product of prime polynomials with integer coefficients. Some polynomials are factored using the distributive property. We look for a monomial that is the greatest common factor of all the terms of the polynomial. This technique is demonstrated on the next slide. So here we want to factor out the greatest common factor from each polynomial. For a, we have 8x to the third power plus 12x squared. What do these have in common? Really obvious to see that they have an x in common. They actually have two x's in common. You could pull an x squared out of both. But what can you also pull out of 8 and 12? Should be able to pull a 4 out of both. So I should be able to pull a 4x squared out of both of these terms. If I pull a 4x squared out of this first term, then essentially if I divide 8 by 4, that leaves me with a 2. And if I pull 2 of these x's out of the 3 x's I have, it remains me with an x there. Now with the second term here, if I pull a 4 out of the 12, that should leave me with a 3. If I pull an x squared out of the x squared, that leaves me with no more x squareds remaining. So my factored form here is essentially 4x squared times 2x plus 3. Okay. Now, the second part looks a little more intimidating. I'll give you that. But if I look at all of them, okay, I'll take it piece by piece. If I look at all of them, they all have an m plus 2 in common. Okay, so the first thing I'm going to do is pull out that m plus 2 and just leave it in a parenthesis out front. And then I'm going to see I'm left with an m to the third minus 3m squared plus m. Okay, I'm not quite done because while I can't do anything with the m plus 2, what does the m to the third minus 3m squared plus m all have in common? What do all three of these terms have in common? They have an m in common. So I'm going to pull an m out of that as well. So it's going to look like, I'm going to put it at the very front too. Doesn't matter where you put it. But I'm going to put it at the front. I'm going to put it at the front like m times m plus 2. If I pulled an m out of m to the third, it leaves me with an m squared. If I pulled an m out of 3m squared, it's going to leave me with a 3m. And if I pull an m out of the m, it just leaves me with a 1. And that would be my factored form. Okay. Now, when a polynomial has more than 3 terms, it can sometimes be factored by a method called factored by grouping. This technique is demonstrated on the next slide. So here we want to factor by grouping. Okay. Now, what I'll essentially do is group the first 2 terms together, and then I'll group the second 2 terms together. Okay. And I essentially want to see what I can pull out of the first 2 terms. What do the first 2 terms have in common? Well, they have a factor of m in common. Okay, I have mp squared plus 4m. They both have an m in it. So I'm going to pull an m out of that first term. It's going to leave me with p squared plus 4. Now let's look at the second term. The second term here, I have 3p squared and I have plus 12. Well, I don't have any variables that are in common, but 3 and 12, well, it has the factor of 3 in common, so I can pull it out. And that's going to leave me with p squared plus 4. Well, now they both have a p squared plus 4. So what I can do now is pull that p squared plus 4 out, and that just leaves me with what was left out in front of each of them, the m and the plus 3. And now I have factored that by grouping. That is factored by grouping. Okay. Factoring is the inverse of multiplying. Since the product of 2 binomials is usually a trinomial, we can expect favorable trinomials with the GCF of the terms equal to 1 to have 2 binomial factors. Thus, factoring trinomials requires using FOIL in an inverse manner. Okay, so we want to factor 6x squared minus 7x minus 5. Okay. To factor this, we must find integers a, b, c, and d such that 6x squared minus 7x minus 5 equals ax plus b times cx plus d. Okay. After a few attempts using FOIL to check, we can find it. Now, essentially, I need 2 numbers that are going to multiply to be 6 to be in the first 2 areas. And I'm going to need 2 numbers that multiply to be -5 in the last 2 areas. Now, we can do this kind of by like a guess and check method. So here we can use 3 and 2, and we can use -3 and -2 if we wanted to for the 6. Or we can use a 6 and a 1 and a 1 and a 6, and we can guess a whole bunch of different ways to try to factor that. Okay. What we can do instead, let's see. So what we can do instead is we can do what I call the X method.